this video, we're going to continue on with sum and difference formulas, and we're just going to do some different kind of questions regarding those formulas. We're still using them, but the question is going to be asked in a different way. So look at this. Find the exact value of the trig expression. So when sine of u is 5 over 13, and cosine of v is negative 3 over 5. Both u and v are in quadrant 2. So the very first thing you're going to have to do on this one is draw out your triangle. If this is quadrant 2, there's two, we actually need to do two drawings, okay? So I'm going to move that down for a second. We need to do two drawings, okay? This one is for angle U, and this one is for angle V, all right? Now U says the sine is 5 over 13. That's opposite over hypotenuse. I know it's a right triangle, and when I do my Pythagorean, I find that this is 12. For angle V, it says the cosine is 3 over 5, negative, so it's negative x values, so I need to put my negative over here as well. And then that tells me, if I do Pythagorean theorem, that this is 4, y's are positive, so we're good to go. Now knowing that, I know what u is, and I know what v is. So I'm going to be finding the cosine of the difference of u and v. So if I want cosine, if I look at my cosine equation here, I need cosine of u and sine of u, cosine of v, sine of v. So to save myself a little time, I'm going to come over here and do a little thinking. So let's figure this out. The sine of u is opposite over hypotenuse, so that's 5 out of 13. Oh, they gave me that, didn't they? Huh. So I need the cosine of u. That would be negative 12 over 13. All right, over here, they gave me cosine. I'm not going to spin my wheels doing that. Negative 3 over 5. So then what would the sine of v be? Well, that's opposite over hypotenuse. All right, now I know my values that I'm going to use in my formula. It's a difference of cosines. So notice it's cosine, cosine, and then the opposite sign. So I'm going to do cosine of u times cosine of v plus sine of u times sine of v. That's where we're going here. All right, so cosine of u is negative 12, that'd be 13ths, not 3, 13ths, times the cosine of v is negative 3 over 5, plus, okay, let's do sines, 5 over 13 times 4 over 5. Okay, let's clean this up. This will be 36 over 5 times 13 is 65, and it would be positive, so plus 20 over 65, and what do we get here? We get 56 over 65, and there's my answer. Okay, so let's try another one here. This one, it says sine of u, cosine of v, both are in quadrant 3. So let's figure out quadrant 3. That's down here. If u is here, sine is opposite over hypotenuse. That would mean my x value is negative 24. So that's u. And then I do the same thing for angle v. It says cosine is negative 4 over 5. So that means that my y value is 3, and it would be negative because we're talking quadrant 3. Okay, from here, let's look at the question. It's tangent. So I'm actually going to be using the tangent formula right here. And notice I need the tangent of these two angles. So let's figure that out. What is the tangent of u? The tangent of u is opposite over adjacent. They're both negative, so it comes out positive. The tangent of v is going to be opposite over adjacent. Both are negative, so it comes out positive. So those are the values I'm going to use in my sum of tangents, okay? On the top it says I'm going to be adding 7 over 24 plus 3 over 4. On the bottom it says I'm going to be doing 1 minus the product. Okay, I'm going to simplify that. That's going to be 8. So my denominator, let's see, be 1 minus 7 over 32. The top, I need to get a common denominator 24, so that would be 18 out of 24. So this would be 25 out of 24. When I do common denominator over here, it's going to be 32 out of 32. Minus 7 gives me, what, 25 out of 32? Okay, so when I keep it. I'm going to keep the top. Change the multiplication and flip the bottom. Oh, sorry, that's 25. And those go away. And then I have 32 over 24. That will reduce. What does it reduce to? Divide by 8. I get 4 over 3. All right, there's my answer. Now the next part of this is asking us to verify the identities and we're going to be using the sum and difference formulas in this. So it's a little weird, but we can do this. We can absolutely do this. Okay, so notice we want to start with the difference of 3 pi minus x, and we want to make it equal to the sine of x. So we're going to start on the more complicated side, which is obviously this, right? And we're going to use the difference in sign equation that we have on our chart. There it is, right there. Now, that being said, let's utilize what we know about the difference of signs. So we're going to do the sine of 3 pi times the cosine of x minus the cosine of 3 pi times the sine of x. We're ultimately trying to make it equal to sine of x, right? So then let's break this down. Let's use our unit circle. What is the sine of 3 pi? Well, where's 3 pi? So here's 0, 1 pi, 2 pi, 3 pi. That's right here. What is the sine there? It's 0. So this is 0 times the cosine of x minus, well, what's the cosine at 3 pi? Well, that's negative 1 times the sine of x. So let's see what happens. This term goes away, and this just becomes the sine of x, which is what we wanted, right? And we're done with that verification. All done. Now look at number 4. Looks a little wonky, right? We have a sum here and a difference here, and we're trying to make it look like this side, okay? So it's going to take some space, but we can do this. So we're going to spell this one out, and we're going to multiply it by this one all spelled out. It's going to be a lot of stuff going on, so watch carefully. Use your formulas. Don't get lost. All right, so the sine of the sum of x plus y was going to be the sine of x times the cosine of y plus the cosine of x times the sine of y, right? Times, now we're doing the differences, the sine of x, cosine of y, minus the cosine of x times the sine of y. All right, that's just what's happening on the left side. Now if we FOIL this out, let's see what happens. Okay, it's going to be gnarly, but we can do this. All right, so we FOIL it out. We have sine x, cosine y. Okay, it's going to become a squared. So it's sine squared x, cosine squared y. Outer terms. Now notice, before we do all that writing, look, sine cosine x, sine cosine y times this, and this, aren't these going to cancel one another out when we do all that work? So sine squared, cosine, it's going to be really, really gnarly. But it's a difference of squares. You see it? Do you notice this pattern? It's a difference of squares, guys. So what's going to happen is I'm going to end up with the first term squared here and the back term squared here. I hope that makes sense. Just like, little sidebar, if I did x plus 2 times x minus 2, we know that that comes out to x squared minus 4, right? First term squared here minus the second term squared here. We just got a bunch of letters attached now. So we're just going to apply that same principle. So this is now going to become cosine squared of x, sine squared of y. Now, what do we do with that? Well, now we're going to use one of our Pythagorean identities. Do you remember the one that says, we can rearrange it and it says cosine squared of x, if you will, is 1 minus sine squared of x or y. That's what we're going to use, and we're going to plug it in here because notice my answer only has signs in it. So we're going to plug that in here, and we're going to plug it in here. We're going to replace cosine y with 1 minus sine squared y. one of those Pythagorean identities off of our chart. So let's see what happens here. Okay, so I have the sine squared x times 1 minus sine squared y minus 1 minus sine squared x times sine squared y. Oops, don't need a parenthesis there. My apologies. All right, got some cleanup work to do here. Right, so let's distribute. We're going to distribute here. So I'm going to have the sine squared x minus sine squared x sine squared y minus, when I distribute here, I'm going to have the sine squared y so I want to be careful with my parentheses, right? Sine squared y minus sine squared x sine squared y. Now I need to distribute the negative. I know it's gnarly, hold on. Sine squared x sine squared y, distribute. This becomes plus right here. Okay, now sit back and look. Isn't this term and this term, aren't they the same? And here we have a negative and a positive, and they're going to cancel out. So what falls out of that? Well, now we have sine squared x minus sine squared y, and that is ultimately what we wanted. So we know we're done. So give yourself space, give yourself room and time to crank through these, okay? But it's just verifying identities like we've done before. All right, so this one is asking us to find the solutions of the equation in the interval of 0 to 2 pi. So basically 1 unit circle. So we need to do a sum of cosines and a difference of cosines. Okay, sum of cosines and a difference of cosines. So let's see what happens here. All right, let's do the sum of cosines first, obviously. It would be the cosine of x times the cosine of pi over 6. There's u and here's v. What does it say? If it's positive, if it's plus here, it's going to be a minus here. So it's going to be sine minus the sine of x, sine of pi over 6. Okay, that's the first thing. Now, minus, what's going to happen on this one? Now we're going to do the difference of the cosines. So the difference of the cosines says cosine of x, cosine of pi over 6, plus sine of x, sine of pi over 6, okay? All of it has to equal 1, apparently, right? So now let's clean this up a little bit. Let's notice some things here. When I distribute my negative, across both terms, hopefully something's going to fall out and make this a little simpler. Well, look at that. This and this are going to cancel one another out, right? And notice these two are pretty much the same, aren't they? And I can combine them. So I mean negative 2 sine x times the sine of pi over 6. All right, now we can utilize our unit circle. Well, what is pi over 6? What is the sine at pi over 6? So let's go to our unit circle. Pi over 6, where are we? Okay, there it is. Sine at pi over 6 is 1/2. All right, so let's plug that into our equation. And it still equals 1, right? All right, now I have negative 2 times 1/2 gives me negative 1 sine of x equals 1. So we're solving now. The sine of x then would be negative 1. Okay, so now the question is, where's the sine of x negative 1? Well, in your unit circle, it's down here. Where is that? Where x is 3 pi over 2. It's the only place on the unit circle where sine is 1. All right, thanks for hanging in there. Make sure you come with questions if you have them, and we'll keep working in class.